Now, I'll walk you through the end-to-end architecture of our LLM-powered materials research platform. We combine at the very front a Streamlit interface where researchers can launch experiments, enter system parameters, or browse past runs with just a few clicks. After that, we have the fast API server, which is running behind the scenes, which handles authentication, route requests, and orchestrates the communication between agents. And that leads to the chat planner, which provides a conversational layer answering questions about workflow, status updates, and troubleshooting tips. Now, going into the core of our research agent, that taps into multiple scholarly and materials databases, where for scholarly, we have the archive, Google Scholar, and also your semantic Scholar databases to extract relevant information and calculation parameters. Now, for materials databases, we have the materials project, OQND, COD, Nomad, and other bulk property databases. Now, for our DFT agent, it is the workhorse for our first principle calculations, and that includes doing the geometry generation, lattice creation, the inputs all the way to job submission, and the post-processing of total energy, span structures, and charge densities. And ultimately, all these calculations are handled in a structured workspace where this data will be eventually handled in an organized manner. Here, let me demonstrate how one can effectively utilize our LLM model. I'll first walk you through selecting the model, loading a prompt, and then running the full DFT workflow automatically. So here I preloaded a prompt asking for magnesium oxide data and DFT guidelines. And so just to give a quick summary, what I've done here is to prompt a property of the MGO from materials project, find papers using MCP paper miner on MGO DFT calculations, extract calculated parameters from literature, generate the MGO surface calculations, and submit these calculations system. And ultimately, the completed calculations should create and report the total energies, which will benchmark with our database. Now, waiting for it to load. Now, just to be ahead a little bit, it should report the properties from the materials project with the material ID, total energy, and bandgap. There you go. It also proposed paper for MGO DFT calculations. Now we have a couple of databases to choose from. Here it also extract calculated parameters from literatures and generate the bulk surface structures based on these recommendations. In addition, it provides your quantum espresso input file directory to your bulk calculation and surface calculations, along with both the job submission ID. And there you go. This is the tutorial for our LLM model.